Let's consider an example how to implement economic order quantity model for a case. We consider a hostel in which we manage the stock of lamps, and we assume that data is the following. D capital demand rate is 100 units per day. We assume that we need 100 lamps per day at our hostel. The next, F capital, fixed cost to make an order, it is $100. For instance, we pay to our purchase manager $100 every time when he makes an order. The next, we assume that marginal holding cost is 2 cents per lamp per day. And also we assume that lead time L capital is 12 days. Marginal cost is $1. We pay $1 per lamp. The question is, what is the inventory management strategy? It means that we should answer to questions how much to order and when to make an order. Let's consider the solution. Let's find an optimal order quantity and we will calculate Y star with the formula 2FD over H and square root. And from this formula we consider 2 times F. F it is $100 and D is 1 units per day. The denominator is H and H in this case is 2 cents. And when we calculate economic order quantity, we will find that every time we should order 1000 lamps. Let's consider the economic order period. To find economic order period, we may consider the formula economic order quantity over D. According to this formula, we get that economic order period is 1000 lamps. This is the economic order quantity over D, and D it is 100 lamps per day, and economic order period is 10 days. Obviously, when we make an order of 1000 lamps, and if we every day consume 100 lamps, obviously we have 10 days to spend all of these 1000 lamps. As we can see, lead time is 12 days and economic order period is 10 days. It is the case when lead time exceeds economic order period. Therefore, we should calculate L efficient, and we implement the formula lead time minus N times economic order period. And if we implement this formula, we will find that L efficient is 12 days, the lead time, minus N. And we may find as integer part of the fraction L, and we calculate like L over T O star and the integer part. And if we use this formula, so we see that L is 12 days, economic order interval is 10 days. So, and if we consider this fraction, and the result is 1.2, and if we consider the integer part of this fraction, so we will get 1, and we should multiply n by TO star, which equals 10 days. So times 10 days. And we see that the result is 12 minus 1 times 10, so it is 2. Now consider the reorder point. Reorder point we may find like L efficient times D, and it is L efficient equals 2 days, D is 100 units. The result is 200. And now let's calculate total average cost for economic order quantity. It is C times D plus 2F DH and square root. And therefore we will get C, it is $1 times D 100 plus the square root from 2 times F, it is $100 times D, it is 100 units per day, and also H it is 2 cents. And the result will be $120 per day. And as we can see in this case, all the measures are at the same scale. So when we consider D, we consider units per day. F, it is dollars. H, it is dollars per unit per day once again. L, it is days. And C, we measure in dollars. So as a result, we do not need to transform any measures to another. So, and we directly implement all the formulas. And the answer is to order 1000 lamps when our stock equals reorder point 200 lamps. And as a result, we get that the total average cost for this strategy is $120 per day. That's it. Thank you for attention.